chapter that is called structure of atoms. Okay, and this thing, for this particular chapter we have covered the basic concepts in atoms and molecules, but then also I will start this chapter from the zero level. So you should understand first of all the word atom. Atom is a Greek word. Atom is a Greek word which is having two partitions in this. One is A and one is Tom. One is A. A means not. A means not, and Tom means it is known as divisible. So what is the full meaning of atom? That atom meaning not divisible means indivisible thing. That is known as atom. This was the Greek philosophy, and this was the word which is according to the Greek language. As you can see here, I have divided this particular thing, and you should know that the who have given this word before in the very first, you should know that according to the John Dalton, all matter are composed of small particles that we can call atom. So everybody just give heading in your copy and just try to start writing in your copy. The very first point about the atoms you should know according to the John Dalton. According to the John Dalton. According to John Dalton. Okay, John Dalton was the first scientist who have given this name of atom. Okay, and according to it, that all matter was composed of small particles called atoms. Write down all matter was composed of small particles called atoms. So do remember this thing, that who have given this particular definition regarding atom? John Dalton. According to the John Dalton, that the particular matter all the matters are was composed of small particles that we can call atoms. So just do remember, and you should know that atom is a Greek word. Just write down in the next line, atom is a Greek word. Greek word, and its meaning is indivisible, and its meaning indivisible. Indivisible. So what is the meaning of atom? Atom is a Greek word and its meaning is indivisible. Okay, what is the meaning of indivisible? That is an ultimate particle, that is an ultimate particle which cannot be further subdivided, which cannot be further subdivided. I hope this point is very clear to you. So whatever I have written at the very beginning of this chapter, that atom, which is, we can say that having the two words, one is A and one is Tom. Okay, and A meaning is not and Tom meaning is indivisible. So what we can say, fully atom is known as indivisible thing, and this is ultimate particle which cannot be further subdivided. I hope this is very clear to you. Anybody doubt? According to the Dalton, but this definition is
Sir,
according to Dalton. Yes? Yes? Anyone doubt?
No, sir.
no, sir.
Okay, but you know that in modern time we have so many different definitions regarding atoms, but this is very beginning of the atom discovery. So when the atom was first defined by the Dalton, then he have defined in this way that all the matters was composed of small particles that we can call atom, And atom was a Greek word. It means that indivisible particle, which is ultimate particle, which cannot be further subdivided. Is this clear to you or not? So
Yes,
one theory was given
yes,
to
sir.
you according to the Daltons, and that we will discuss here. According to Dalton's theory, some points he have given about the atoms, okay, that we need to discuss here. First point, what did he say? He said that atom is the smallest indivisible part of matter. Atom is the smallest indivisible part of matter which takes part in chemical reaction, which takes part in chemical reaction, chemical reaction. So do understand one thing, atom is the smallest particle or indivisible particle of matter which takes part in chemical reaction. This was the first conclusion given by the Dalton about the atoms. Second one, what was the thing according to the Dalton's theory? Atom is neither created or never be destroyed. Atom is neither be created, is neither, everybody mute, neither be created nor be destroyed, nor be destroyed. Okay, so what is the meaning of this? That we cannot generate one atom and we cannot destroy it also. But nowadays in modern practice, it is possible. By the nuclear chemical reactions or nuclear reactions, it is possible to generate the new atom and it is possible to destroy the one atom. So this was also a wrong point was given by him, but according to him, at that time, the discovery was not happened regarding nuclear reaction. So that's why he have given his statement like that only. Write down the next point according to Dalton's theory that atoms of the same element are similar. Atoms of the same element are similar in size, are similar in size, comma mass and characteristics. Okay, but you should know that it is also a wrong point. In further studies, we found that a single element could have the more than two type of the atoms. Okay, are you getting my point? More than one kind of the atoms are possible for a similar elements. So what we can say, however, atoms of different elements have different size according to it. Just write down, however, atoms of elements different elements have different size, comma mass and and characteristic. But you should know that this point is wrong because the atoms of the dissimilar atoms or similar elements, or you can say the atoms of different elements, could also have the same mass that we call as a isobars. So that we will discuss what are the demerits of this theory one by one. First of all, these points are very clear to you or not? Is there any problem with these 3 points? Tell me yes or no.
No, sir.
Very
No,
good. There is
sir.
no issue then. Okay. So first of all, you should write down very basic information regarding the atom, which we know right now in modern theory of the atoms. what we know, the basic theory about the atom, you should note down here. Basic points of atoms. Write down in this. An atom is made up of an atom is made up of three subatomic particles, three subatomic right. Yes, everyone, I was telling you that an atom is made up of three subatomic particles, note down this. Electrons, you know very well that what are these three particles, but for just writing purpose we are just writing it. Okay, write this. Three subatomic particles, okay, electrons, comma, protons, and neutrons. Note down this. Electrons, comma, protons, and neutrons. Okay. And what we call these three particles, we call these three particles as fundamental particles. Electrons, protons, and neutrons are called fundamental particles of an atom, of matter, you can say, of matter. Complete these 2 points first in your copy. Fundamental particles. I hope these things are clear to you. So first of all, we will just write some informations regarding the electron, proton, and neutron. Then we will move further. So I will write here the particles one side. Particles, okay. And the scientists who have discovered them and scientists who have given the name of these, I will write here the name of scientist. Here the charge and mass. Okay, first of all, if I will talk about the first particle that we can call electron. Electron used to represent with the symbol small e. At the head of this e, you can just represent the negative charge. This is electron. If I will talk about the scientist, then J.J. Thomson. J.J. Thomson. The charge on electron is negative charge, but its magnitude is minus 1.6 into 10 to the power minus 19 coulomb. Similarly, mass of electron is 9.1 into 10 to the power minus 31 kg. Minus 31 kg, kilogram. Similarly, if I will talk about the proton, proton is having the symbol is P, and neutron, the last one I will tell you. First, just let's talk about the proton. E. Goldstein was a scientist who have given this name. Okay, it is having the positive charge, positive 1.6 into 10 to the power minus 19 coulomb. And its weight was 1.67 into 10 to the power minus 27 kg. Next one is neutron. It is small n, and it was James Chadwick. its charge is 0, okay, and its weight is 1.675 into 10 to the power minus 27. As you can see here, approximately the weight of proton and weight of neutron, mass of proton and mass of neutrons are similar only. There is no such big difference in these two. Is that clear?
Yes, sir.
Good.
Yes, sir.
Complete these all points. Good. Okay, you tell me one thing. If I will compare the mass of proton with mass of electron, if I will compare the mass of proton with mass of electron, can you just tell me how much times of mass of electron will be less than mass of proton? Can you just tell me? Can you just tell me what is the mass of proton in terms of the mass of electron? How many times of mass of electron? Okay, this I will just ask you this question here itself. Write down a question in your copy. Calculate ratio of mass of electron or mass of proton. Calculate the ratio of mass of proton with mass of electron. Calculate the ratio of mass of proton with mass of electron. You need to calculate it. Just do this. So what you need to do, you have to write down the mass of proton at the denominator, and numerator you have to write down mass of electron, and that you need to write here the assign the values. What is the mass of proton? 1.67 into 10 to the power minus 27, and mass of electron is 9.1 into 10 to the power minus 31. Wait a second. Hmm. 9.1 into 10 to the power minus 31, and if you will take the ratio, it will approximately come out as a 2000, okay, in a round figure. Okay, this is the round one. Everybody just try to understand, this is a round figure I have written. So can I say that mass of proton is 2000 times more than the mass of electron? Yes or no?
Yes, sir.
More than the mass of electron. Important point it is. Just note down. And the mass of proton is approximately equal the mass of neutron. Mass of neutron. Mass of proton is approximately equal to mass of neutron. As you can observe with these data which we have written before, as you can see 1.67, it is 1.675, 10 to the power minus 27, 10 to the power minus 27 kilogram. So at least they are having the same weight approximately. So that's why I have added this point here. Is this clear, everyone? Any doubt in this?
No, sir.
Very good. Okay. Okay, so one more thing I'm just going to tell you. Already I told you this thing, that what is mass number. You should again know this thing, that what is mass number. Mass number is nothing. This is just the number of protons. 1 minute. It is just equal to number of protons plus number of neutrons. Number of neutrons. Number of neutrons. That is known as mass number. So like suppose if I will talk about the example, mass number of sodium, like suppose Na. So we know that what is the atomic number of Na? It is 11 and mass number is 23. 23, how it will be? Everybody just try to understand this thing that 11 number of protons are present. So I will write here number of protons plus number of neutrons. So protons 11 plus neutrons, it is 12. So total is equals to 23. 23 number mass number. Okay, this is the mass number. Mass number. Anyone doubt in this? Is this clear or not?
Yes, sir. Clear,
Okay. Then let's talk about the next one, that is called atomic structure. Means we are just going to define that how the atoms looks like. Okay. So just write down atomic structure.
Yes, sir.
Atomic structure. You should know that atom is made up of two parts. One is inner part and one is outer part. Okay. So let's just look at the screen, everyone. I'm just going to define here that what are the different parts of atoms are there. So if suppose this is an atom, then this is having two parts inside it. Means two parts it is having. Just a second. Yes, at the center. Correct. Yes. Now everybody just try to understand with the help of this diagram which I have drawn here. So as you can see that this is known as outer part. This is known as outer part. And this one is known as inner part. This is known as inner part. Okay. So whatever the outer part we have, in this outer parts, electrons will be placed. Okay. Electrons are there. So in this outer part, electrons are present. Electrons are present. Okay. In outer part. But in case of the inner part, protons and neutrons are present. Are present. So do remember this thing. This is just like your home. If suppose you guys are 4 members in your home and you guys all are having the separate rooms. So what we can say in this particular case, that you are having your own space inside your home. Am I clear to you or not?
Yes, sir.
Very good. So
Yes,
whenever
sir.
I will talk about the outer part, this outer part which contains the electron, this outer part will be known as orbit. This outer part will be known as orbit. But if I will talk about the inner part, this inner part will be known as a nucleus. Okay, this is known as inner part will be known as nucleus. Inner part will be known as nucleus. So these two things we will discuss. There are two parts of atoms. Okay. So I'll just add this point here. There are two parts of atoms. First one, inner part, or which is also known as nucleus. And the second one is outer part. Okay, in which electrons are present. So first of all, I'm going to define the nucleus here. Okay, everybody, is this clear or not? I hope this diagram is clear to everyone.
Yes.
Very good. Okay, everyone just look at this screen now. So first of all, we are just going to define the first part, which is called nucleus. Yes. If I will talk about the nucleus, then the size of the nucleus of an atom is very, very small. What I'm telling you, just listen to me carefully. The size of a nucleus inside the atom is very, very small, in which neutrons and protons are present. So the almost entire mass of the atom is situated in the nucleus. Why? Because I told you that what is the mass of proton? It is just 2000 times more than, rough figure it is, okay? This is a round figure. 2 times more than the mass of electron. So can I say that mass of proton and mass of neutron is very heavier as compared to the electron? Yes or no? Anybody, is this clear or not? Anybody doubt in this?
No, it is clear, sir.
Very
No,
good.
sir, it's clear, sir.
So by the help of the mass values, easily you can observe the mass of the protons and mass of neutrons are much higher, or it is more than higher as compared to the electrons mass. So that's why whenever we will talk about the entire mass of the atom, then it will be covered by the mass of protons and mass of neutrons, which is situated in the nucleus. So first point I will write in the nucleus. First point in the nucleus I will write here. The size of nucleus of an atom, the size of of nucleus of atom is very small, in which neutrons and protons are present. So the entire so almost the entire mass of an atom is situated is situated is situated in nucleus in nucleus. So just do remember this thing. Okay, let's compare the size of an atom and with the size of a nucleus. Just try to understand one thing. Just take an example of a football playground. Okay, just try to understand with the help of football playground. Suppose this is a football playground we have, okay? This much big. As you can see, the football playground, this much big it is. And suppose at the center of this football playground, if I will keep one football, then can you compare the size of the football playground with respect to the football? How much bigger it is as compared to the football? Yes or no? Are
Yes,
you getting
sir.
my point? Yes.
Yes,
So
sir.
as you can see, the mass means the size of the football is very, very, very small as compared to the size of football playground. Similarly, the atoms are having the very large area, very large space as compared to the space of nucleus, because nucleus is just like a football in football playground. This is only comparison I'm telling you, but atom is not this much big. This is only for comparison. Okay, anybody there doubt in this? Is this clear to everyone?
Yes, sir.
Very good, correct it is. Okay, so as I told you just now that protons and neutrons are situated inside the nucleus, which will cover the almost entire mass of the atom. You know that protons and neutrons present in nucleus, they collectively known as nucleons. Just write down in this point also you should add in this. Protons and neutrons protons and neutrons protons and neutrons present in the present in the nucleus are collectively termed as nucleons. nucleons, are termed as nucleons. Okay. So just now I told you what is the mass number. Mass number is equals to the number of neutrons plus number of neutrons. This is known as mass number. And if I will talk about the atomic mass means number of protons. So I will just add these two points also here, that what is the meaning of atomic mass. Atomic mass is equals to number of protons in nucleus. Okay. Sorry. In nucleus. But if I will talk about the mass number, it is number of protons plus number of neutrons. I hope these two things are very clear to all of you. Anybody doubt in this?
No, sir.
Yes, very good. Okay, so can I say that number of protons and number of electrons are equal in an atom? So just write down atom is electrically neutral. Electrically neutral. Neutral. What is the meaning of electrically neutral? Because number of protons or positive charge is equal to number of electrons or negative charge. So that's why the atom is electrically neutral, because number of protons are equal to number of electrons. That's why this is known as a neutral species. Yes. So we have discussed some things regarding the nucleus. Now we are going to discuss the outer part of the atom. Second one, outer part. Outer part. So if I will talk about the outer part of an atom, okay, you should know that in the outer part, electrons move around the nucleus in a fixed orbit. As I told you, orbits are present in outer part. In a fixed orbit, electrons will move around the nucleus. And these orbits are called energy levels. I will tell you how it will be. Just a second. First of all, everybody just write this point in copy. In the outer part, electrons move around the nucleus around the nucleus in fixed orbit, and these orbits are called energy levels. Write down these orbits. Everybody mute first. Orbits called energy levels. These orbits called energy levels. Okay, now try to understand how these energy levels or orbits will be in an atom. Okay, suppose if I'm talking about an atom, so as I told you, there are two spaces in the atom. One is inner space and one is outer space. 1 minute, I will tell you everything. Just a second. Just a second. Okay. So everybody just look at the screen here. I will show you one diagram. So with the help of this diagram, you can easily understand what my meaning is. Just a minute. Let me draw one more circle inside it. Correct. So as you can see, I have drawn the two many circles inside the particular atom. So as I told you that the mediator means the inner one shell means inner wall space is known as, this is inner space. It is known as nucleus. It is known as nucleus. But if I will talk about the outer space, these all are outer space only. These are outer space. And these are the white type of the circles are representing the orbits. These are the orbits. Just a second. These all are the orbits. Orbits in which electrons revolves. Okay. In which electrons revolves. Okay. Try to understand. The electrons are present at the outermost, means in outer circuits, or you can say in outer part of the atom. But the protons and neutrons are present at the inner part. So protons plus neutrons are present in inner part or nucleus. Am I clear to all of you? Anybody doubt in this? I hope this is very clear to all of you.
No, sir.
Very good. Correct, it is. So this is the structure of atom, by the way, of atom. Do anybody have doubt in this? If you have, you should ask me right now. And these orbits are known as energy shell, which I forget to tell you here. These are known as energy shells. These are known as energy shells or orbits. Is that clear? Anyone doubt?
No, sir.
Okay, this is it for today then, and we will study the next topic in next class. Thank you, everyone. We will meet in the next class now. Thank you.
Thank you, sir.
Thank you, sir. Thank you.